we are going to discuss electrical elements. Okay, so what are these electrical elements? Electrical elements are circuit elements or network elements. Okay, electrical elements, you can also say that circuit elements are network elements. These are nothing but voltage, current, resistor, inductor and capacitor. Okay, that is nothing but it is a family of electrical elements. It is the family of electrical elements. In these family, voltage comma current, these are like parents, father and mother, like parents. Here parents will give the supply to the children. So resistor, inductor and capacitor, these are the nothing but like children. Okay, in these also this resistor is like a boy, this inductor and capacitor are like girls. Okay, so I want to discuss about this in a recent manner. Here voltage and current are nothing but give the energy to the device, to the devices like resistor, inductor and capacitor. These are RLC or receives the energy like children. Okay, that is parents giving the food to the children, children taking that food. Now we are going to discuss here in these electrical elements, we can divide it into two. One is nothing but active elements and another one is nothing but passive elements. What are the active elements? Active, they are active, that means they are ready to provide, they are giving the energy. The devices are the elements which are giving the energy is nothing but you can say active elements. And passive elements are nothing but which are receiving the energy, like children. Children receives the food from the parents. Okay, in that this resistor is a dissipative element. Resistor is a dissipative element. Dissipative element. Whatever the food or money provided by the parents, he simply dissipate. He simply spend that one. Okay, but in case of girls, those are storage elements. Storage elements. They stores the energy. Okay, we know very well. For example, parents given some money to the girls, then they will store some amount of the money there, into them. Okay, so that means they store some energy. In this C is a younger girl, younger one. Okay, younger sister. So we have to be careful. We have to be careful with the capacitor C. Okay, so electrical elements we can divide it into two. One is active elements and another one is a passive elements. Active elements are nothing but voltage and current. Passive elements are nothing but resistor, inductor and capacitor which are receives the energy. So we can take those as active elements. Nothing but which given the energy. You can also say that which are used to, which are energized or given out, which can deliver, okay, which can deliver or drive electrical supply, drive electrical energy. Okay, which gives the electrical energy, which energizes the electrical energy, which delivers or which drives the electric current is nothing but you can say active elements. Example, nothing but voltage comma current sources. Okay, voltage comma current sources. Here we have to understand one important point. For example, if you have one voltage source like this, okay, if the current is flowing like this, that means if it is delivering, okay, if it is delivering the power, then we can say power deliver is positive. Okay, power deliver is positive. If it receives, for example, in case of if any source absorb the power, If any source absorb the power, then power is negative. These are the two important points we have to understand. Okay, if the source is delivering, that is the actual nature of the element. Okay, am I correct or not? Source is delivering means the power dissipated is positive. Instead of delivering, it is absorbing means you can say power is negative. Okay, in the same way, coming to passive elements, these are the important for exams. Passive elements, these are nothing but which receives the energy. Receive or dissipate. In case of inductor and capacitor, stores, which can receive, dissipate, store, or waste, or convert. Those devices are nothing but convert electrical energy. Those are nothing but you can say passive elements. For example, which receives the energy, RLC. Okay, which receives the energy. So we can say at a steady state, all these definitions are belongs to steady state. Okay, so not at transient, So we can say receive, dissipate, or store, or waste, or convert electrical energy for a long time. For a long time, that means steady state. Here also can say that energy for a long time. For example, the stored capacitor may be act as the voltage source, but it can give the voltage with very little time. Okay, only in case of transient time, a very little second. So that's why we can't say that capacitor is a active element. Okay, capacitor is a active element. So RLC are passive elements. If they have energy, if they deliver the electrical energy for a long time, then only you can say active element. Okay. Now, after this one, we have to understand linear and non-linear elements. The difference between linear and non-linear. Linear and non-linear. It is also very important, friends. Coming to the linear elements. The elements which follows the superposition, then we can say those are linear elements. Okay, so we can say all the components which follow or which obeys superposition. Superposition means homogeneity and additivity. Okay, homogeneity means proportionality. One is proportional to another one. Proportionality. Okay, if it is directly proportional, for example, V proportional to I. So it is a directly proportional. So directly proportional means you are getting, if it is a current, if it is a voltage, you are getting linear relation. So here linear relation you are getting, and R is equal to V by I. So here resistor will use the linear relation. So resistor is said to be linear element. Okay, so if it is one is increases, another one also increases, then you can say homogeneity. So here this resistor follows the superposition. So it is nothing but you can say linear element. Okay, R, if it is V proportional to I, that is R, so it is also giving the Ohm's law and also obeys the Ohm's law. So which obeys superposition? R, you can say Ohm's law, Kirchhoff laws, additivity case. If it is following additivity means that is Kirchhoff laws, algebraic sum. Okay, Kirchhoff laws, superposition, that is homogeneity, additivity. We can say those elements are linear elements. Example, RLC follows the linearity. Okay, so then we can say those are linear elements. Okay, so we can also say that the linear elements are those whose VI characteristic, voltage and current characteristic, voltage and current characteristics, straight line passing through the origin, straight line passing through origin. Okay, for example, let us take a resistor. I have already given now. So it is the response is straight line passing through the origin. Okay, those are nothing but linear elements. Example RLC. And what about non-linear elements? Non-linear elements. Okay, non-linear elements. Non-linear elements are those which may not obey like previous, which may not obey superposition, that means homogeneity and additivity, and Ohm's law, Kirchhoff law. Those are nothing but, you can say, non-linear. For example, diodes, diode, transistor, SCR, all those. What is the response of the diode? Here we are getting the response of the diode like this. Okay, so that is non-linear. It is a non-linear. So non-linear devices are nothing but which may not obey the superposition, Ohm's law, Kirchhoff laws, all those. Nothing but we can say not devices. Those are example diodes and transistor. Okay. So once again about active elements and passive elements. Here active elements are those which delivers the electrical energy for a long time, voltage and current sources. Passive elements are nothing but which receives the energy for a long time. Here I have given if the power is delivered positive, if the power is absorbed is negative. In the same way, coming to these passive elements, here what is the nature of these passive elements? They are absorbing. Absorbing means whenever they absorb the power, you can say that is a positive. If instead of absorbing, if they deliver means that is negative. For example, let us take a resistor. If this resistor is absorbing the power in this direction, then you can say it is the positive power. Power is the positive. Instead of absorbing, it is delivers. If it is delivers the power, then you can say power is negative. Power is negative. Okay, so like that we have to understand. As the nature it follows positive. Okay, sources, power delivering. So those are positive. Loads, resistor, inductor, capacitors are nothing but we can say passive elements. That is nothing but we can say loads. Loads are generally absorbing the power. If they absorb, that is a positive. Okay, as per the nature, it behaves as opposite. That is nothing but negative. Okay, I think we got. Linear and non-linear, if it follows, if the voltage and current response or characteristics are a straight line passing through the origin, it is a linear. Otherwise, it is a non-linear. Okay, RLC are linear and diodes, transistors, SCRs all are non-linear. Okay, we are going to discuss unilateral and bilateral devices. Okay, bilateral and unilateral devices. Let us consider first of all bilateral and unilateral devices. Okay, so first of all, coming to the bilateral. As the name itself, we have bi. Okay, bi means two. So that means two means either direction. Either direction. Okay, either direction. So that means you can say if the properties are same, if properties are same in either direction, in any direction or either direction, you can say those are bilateral. Okay, so properties are same in either direction. That means, for example, you can say the response. The response is independent to to voltage polarities plus minus, voltage polarities, current directions, upward or downward or forward or backward. Okay, so if the response is independent to voltage polarities and current directions, then those are nothing but we can say bilateral. For example, let us take example resistor. Okay, resistor, let us take one resistor like this. It has, let us take 2 ohms. If the current flowing through this in this format as 2 amps, then what is the power, friends? I square into R now. That means 2 square into R, that is 8 watts. For example, if you are going to reverse the current is flowing like this, then what is the power, friends? What is the power? Again same I square R, 8 watts now. So that means power response, the response is same. Okay, if you reverse the direction also, if we reverse current direction also, if we reverse current direction also, magnitude of power is same. Power is same. Okay, so those devices are nothing but you can say bilateral devices. Example, passive elements R, L, C are considered as bilateral. Okay, so the response may not change as per the voltage polarities and current directions. That means response is independent to voltage and current polarities. Okay, let us discuss about unilateral also, then you will get a clear idea. Coming to unilateral elements. Unilateral elements. Here response is not same. Response is not same. That means you can say response is dependent on voltage polarities, current directions. Voltage polarities and current directions. Okay, so that means you can also say that properties are not same in two directions. Okay, so for example, let us take a diode. Okay, here we have one resistor maybe having 2 ohms. If you are applying voltage as 2 volts, okay, then in this first case what is happening? Positive is connected to anode, negative is connected to cathode, means it is in the forward bias, so it will be act in the short circuit. Then what is the current flowing through the diode? Current flowing through the diode is nothing but voltage by resistance 2 by 2, that is equal to 1 amp is flowing. Okay, in the second case I am reversing the voltage polarities. Anode is connected to negative, cathode is connected to positive. Okay, here we have your resistor 2 ohms, here 2 volts. Then it is negative is connected to positive, that means it is nothing but reverse bias. Reverse bias, it is a open circuit now. Now the circuit is belongs to like this. Then what is the current flowing? That is 0. So that means if you change the voltage polarities, you are getting a different response. Here 1 amp, here 0 response. That means response is not same in case of bilateral networks. Okay, so for example of this bilateral network, we can say diodes, transistors, and SCR like this. Okay, SCR like this. So these are nothing but you can say unilateral. Bilateral response properties are same in either direction, but here not same. Okay. Now coming to the next classification, lumped and distributed network. Lumped and distributed network. Okay, this is nothing much important. Okay, just we have to understand. Lumped means generally you can say small. Okay, general meaning. So that means, for example, if the circuit is the circuit elements having, I mean, for example, lumped circuit means a small circuit. Circuit is very small, not distributed and not having parameters are distributed. Okay, that means you can also say that a small portion of distributed network. That is nothing but you can say lumped network. What is this distributed network? It will be the parameters are distributed throughout the length. It is a parameters are distributed throughout the length. For example, transmission line parameters. Transmission lines. Okay, power transmission lines. In case of power transmission lines, how we can modeling the resistor? Resistor will be throughout entire length. Okay, as the length is more, resistance is also more now. Inductance is more and capacitance also more. Okay, so in this case, the total network is nothing but you can say distributed network. In this, a small portion, if you can consider a small portion, that small portion is nothing but lumped network. So why we are using lumped network? To understand the transmission line. In case of you can say short transmission line, we are going to take a lumped network and we can adapt that one to a total network. Okay, so these are the lumped network and distributed network. Apart from this, there is a very important concept is there. Okay, so sometimes they will give the response and which type of network it is. So we have to understand that one. I want to give in detail about this. All of you listen carefully. That is a very important one. So I'm going, response is maybe, for example, you can say VI response. It may be having 4 quarters: first quadrant, second quadrant, third quadrant, fourth quadrant. Okay, so if the response is VI response lies, if VI response lies first and third quadrant, then you can say those are passive elements. If the response lies second and fourth quadrant, those are nothing but you can say active elements. Okay, so let us try to understand. For example, I am going to take the resistance as the example. What is the resistance response? Resistance response is nothing but as the voltage increases, the current also increases. Okay, so that is nothing but we are getting linear. Okay, so this is the resistance response. So the resistance response is lies in the first quadrant. So you can say it is a passive element now. Yes. Okay, it is a passive element. If you increase in the negative voltage or negative current side, the resistance may be here you are getting this like this. So that means you can say that here it is also linear, that is third quadrant. So that is a passive elements. Okay, so in case of passive elements, the response is lies 1 and 3. In case of active, that is 2 and 4. We can also understand this one. All of you listen carefully according to the power. Here in the first quadrant, the first quadrant. What about the power, friends? Voltage is positive, current is positive. So power is positive. Okay, for the load, power is positive means power is absorbing. Absorbing means you can say passive. Am I correct? Here also, let us take minus I minus V. So what about the power? Power is minus into minus plus positive, that is absorb. Power is absorbing means passive. Let us take the second quadrant. What about the power? Positive and negative. Negative. Power is negative means deliver. The load power is negative means that is load is delivering the power. So deliver. Deliver means that is nothing but active. Okay, here fourth quadrant, minus into plus, minus. So power is minus. Power is minus means power is deliver. Okay, deliver means active. Active. Okay, so we can say 2 and 4 are active elements. 1 and 3, that is nothing but passive elements. And one more important thing, if the first and third response is symmetry, same type of response, we can say the symmetry, then those are nothing but we can say bilateral. Okay, for example, resistance. Resistance is bilateral na? If the first and third is not equal to, we can say those are nothing but unilateral. Unilateral. Okay, this is a very important one. If you know this one, we can easily get the answer. Let us take one example. Students, don't feel I am moving the fast. Here we have the facility that if you are not getting, you can watch again. That is the feature here. Okay, so let us take one response of the circuit. For example, if the response is like this is the response, then which type of network it is? Okay, which type of network it is? So coming to the answer, it is, first of all, it is non-linear na. So linear means it must having the proportionality. So from this point, it is a linear. From this point, it is a constant na. Constant means it is non-linear. So it is a non-linear curve. So non-linear network, and it lies in first and third. First and third, you can simply say that it is a passive. Okay, and first and three are not symmetry. Not symmetry. So you can say unilateral. Say unilateral. So it is a non-linear, passive, and unilateral network. Okay, like that you can use the series and parallel connection of the elements. Series and parallel connection of the elements. Okay, so first of all, let us take series connections of elements. Of elements, I mean passive elements. Okay, series connection of passive elements. Let us take first of all a resistor. Okay, I want to give all the important points. If the resistors are connected in series, let us take R1 and R2, then the total resistance is equal to, the first point, the total resistance is equal to sum of the resistances R1 plus R2. If we have so many resistors Rn, okay, Rn, then we have to add like this R1 plus R2 plus and so on Rn. And coming to the second one, in the series connection, same amount of the current is flowing. So if you can consider I1, it is the I2, it is the IN, the total current is, let us take I total, all the currents are same. Okay, the current through all the elements is same. I total is equal to I1 is equal to I2 is equal to and so on IN. Okay, the third point, if the resistances are different, then what is the voltage drop across this one? Voltage as per the Ohm's law, V1 is equal to I into R1. Voltage across 2 is equal to I into R2. voltage across 3 is equal to I into R3. As the resistances are different, the voltage drops are also different. Okay, so voltage drops will be as per the resistances, as per the resistances. Okay, so total voltage drop is equal to sum of the voltage drops V1, V2 and so on Vn. So V1 plus V2 plus and so on Vn. So in series connection, voltage drops are added. The voltage drops are added. Okay, that is a very important one. And now coming to the fourth one. If all the resistors are same, if all series resistors having same value, that is R1 is equal to R2 is equal to and so on is equal to Rn is equal to R, then what is the R total? Okay, so R plus R plus R plus R plus means that is n times of the R, okay. So if two resistors are there, two of the resistors are equal values, then R total is equal to R by 2. So the resistance is going to be off. And here always the R total is greater than the R value which is high in circuit, series circuit. Okay, so the total resistance is always greater than the resistance is high in series circuit. Okay, so for example here one is the high resistance 100 ohms, remaining 10 1. So you will get 111, that is 311 you are getting. So 311 is always greater than the higher value, so always greater than the 100 na. So like that. So in series connection resistance will be added, so the resistance is going to be increases. Okay, currents are same, voltage drops are as per the resistances. The total voltage drop is sum of all the voltages. Okay, and coming to the same concept in case of inductances, if you can consider inductance. Okay, here also same, inductance formulas are same as that of the resistances. L1 L2, L total is equal to L1 plus L2 plus and so on Ln. Okay, so the inductances are added only. And coming to the capacitors, in case of capacitors, if you connect the capacitors in series, that is a different. So here coming to the C total means here in series connection the reciprocals are added. 1 by C total is equal to 1 by C1 plus 1 by C2, like that. Okay, if we have the Cn, 1 by C total is equal to 1 by C1 plus 1 by C2 plus and so on 1 by Cn. So capacitance formulas are different from the resistors, resistor formulas. Okay, now coming to the parallel connection, of elements. Okay, coming to this parallel connection of elements, let us take example as a resistance. First of all, coming to the resistance, if the resistors are connected in parallel like this, that is similar ends are connected together, you can say that is the parallel connection. It is R1, R2 and so on Rn. Okay, if you have the total voltage is Vt, here if you can consider it is a V1, it is a V2 and so on Vn. Whatever the voltage across these 2 points, the same wire, just a wire is connected means same voltage drop across this one, same voltage drop across this R2, same voltage across this Rn. Okay, and here the first point, reciprocals of resistances are added. To get the total resistance, reciprocals are added. 1 by R1 plus 1 by R2 plus and so on 1 by Rn. Okay, and the second one, currents are not same. Current through all resistors not same, and divide as per resistance. Okay, so higher the resistance, lower the current, and voltage across all elements is same. Voltage across all the elements is same. Okay, that is, let us take V total is equal to V1 is equal to V2 is equal to and so on Vn. Okay, and the fourth one, if all resistors are same, okay, that is R1 is equal to R2 is equal to and so on Rn and so on Rn, then R total is equal to R by N. Okay, resistance is divided, and here also the total resistance is always less than that of low resistance in that circuit. Lower resistance in the circuit. Okay, for example, if we have the n number of resistors, one is 1 is 100, one is 1000, like that. If you are going to calculate also, then you are getting R total is always less than low value, that is nothing but less than 1 ohm only. That is the concept. Okay, coming to the next one, inductance formulas are same as that of the resistor, but capacitance formulas are different from resistor formulas. Okay, so if you connect the two capacitors or any n number of capacitors in parallel, C1 C2, then C total is equal to C1 plus C2. So just capacitances are added here. Okay, yes.